Hello everyone, myself Nanjan Swami, Department of Chemistry, JSS Academy of Technical Education, Noida. This lecture I am going to explain one of the experiment in the chemistry practical lab, that is the determination of viscosity of a given liquid. For that, what are the apparatus is required to perform that experiment? First, the Ostwald viscometer, stopwatch, rubber tubing, and distilled water and a given liquid. These are the apparatus which are required to determine the viscosity of a given liquid. Before going to perform that experiment, what is the theory behind this experiment? First we should learn. First I am going to explain the theory. Viscosity arises due to the internal friction between the moving layer of a molecule. We already know that one. In that, a liquid flowing through a cylindrical tube of a uniform diameter is expected to move in the form of a molecular layer. Means a layer is close to the surface is almost stationary, while the axis of the tube moves faster and exerts a drag or the friction on its nearest moving layer backwards. Means these are all the properties of a liquid by which it retards or opposes motion between the layer is called viscosity. Means generally the viscosity definition is the viscosity of a fluid is a measure of its resistance to deformation at a given rate. Correct? Means the viscosity of a fluid is a measure of its resistance to deformation at a given rate. The viscosity of a fluid means the coefficient of a viscosity. The coefficient of a viscosity is the general representation. The mathematical term is eta. It's like n. Eta means it is defined as the tangential force per unit area required to maintain unit velocity gradient between any two successive layers of a liquid situated at unit distance apart. Means in order to determine the viscosity coefficient or coefficient of the viscosity of a given liquid, we are going to using Ostwald viscometer. There are several types of viscometer is there. To determine the viscosity of a given liquid in our experiment, we are using Ostwald viscometer. In this method is based on the Poisson's equation. What is that equation? You can see means the equation are visible on the screen. Eta is equal to pi r to the power of 4 into t into p divided by 8 into v into L. This equation relates the rate of flow of a liquid through the capillary tube with the coefficient of a viscosity. In this equation, the eta represents the coefficient of a viscosity and V represents the volume of the liquid flowing in time, and time represents T through the capillary tube of the radius represents R, and the length of the tube is L, and P is the hydrostatic pressure of a given liquid. Suppose this is the Poisson's equation. This Ostwald viscometer is based on this method. Suppose if the two different liquid of equal volume, are allowed to flow through the same tube under identical conditions. At that time, T1 and T2 or the flow times are required to flow for the equal volumes of the two different liquid through the same length of the capillary. Then the Poisson's equation is Eta 1 is equal to pi r to the power of 4. The time is t1 p1 divided by 8 into v1. The length is c. The height of the liquid, h represents height of the liquid column, d is the density of the liquid, g is the acceleration due to gravity. Why this height, density, acceleration due to gravity is required? Because the pressure, the hydrostatic pressure P is equal to HdG. HdG. Same thing if the second liquid, the Poisson's equation eta 2. And when comparing these two, eta 1 and eta 2, mean by comparing the two liquid coefficient of viscosity, we will get the equation eta 1 divided by eta 2 is equal to P1 T1 divided by P2 T2. P1 T1 divided by P2 T2. On comparing these two liquids, on comparing liquid 1 and liquid 2, we will get the final equation is eta 1 divided by eta 2 is equal to D1 T1 divided by D2 T2. If we know the viscosity and density of the one of the liquid, we can easily determine the viscosity of the other liquid. Means by using this Poisson's equation, we are going to determine the viscosity of the given liquid by using one of the liquid as a reference. Clear? Okay. And now what is the, means how the Ostwald viscometer is there? What is the diagram? Okay, you can see on the screen the figure represents the Ostwald viscometer. Okay, in that the U-shaped tube. In that U-shaped tube, we are marking, means we are representing A, one of the end of the tube A, and other end mark it as a C. In that at the end of the C to below upper mark is there. That upper mark represent as X. That below the upper mark is lower mark. The lower mark representing, mark it as Y. The opposite to this tube we are marking as B, means representing it as B. In that B, at the end of the B is A. Okay, this is the flow, or else this is the diagram of Ostwald viscometer. Okay, these are the theory behind the viscosity experiment. Okay, how we will going to determine the viscosity of the given liquid? What is the procedure to perform this experiment? Okay, let me explain. First, take a clean and dried Ostwald viscometer. Okay, you can see on the screen the same viscometer. The viscometer, it should be clean and dry, and then attach a piece of clean rubber to the end C of the viscometer. See where? Here attach a piece of clean rubber tube to the end of C of the viscometer and clamp it vertically in the air. Now introduce a sufficient volume of distilled water here. Introduce a sufficient volume of distilled water with the help of pipette or measuring cylinder and the bulb through B, so that the bent tube of U-shaped U-tube and more than half of the bulb B are filled up to here. If you fill from this side, the liquid will fill more than half of, fill it up to here. The liquid will present here. Through this rubber, see, through this rubber, here we fixed rubber, attached rubber. Through the rubber tubing, suck up the liquid until it rises above the mark X. until here. Next, now allow the liquid to fall freely through the capillary up to the mark X and start the stopwatch and note down the time T1 for the flow of liquid from X to Y, from here to here. Okay, before going to taking the reading, first we'll note down the room temperature, means the ambient temperature. Clear? Next, after note down the temperature, we are repeating this experiment thrice or 4. Take 3 concordant readings. Repeat the same experiment. Take 3 concordant readings. What is that? Introduce a sufficient volume of distilled water with the help of pipette or measuring cylinder in bulb B through the end of A, so that the bent portion of the U-tube and more than half of the bulb B are filled up. After filling, means first once we filled the distilled water, no need to remove again and again. Means after filling the water to the B tube, suck the water, means through the rubber tubing, suck up the liquid until it rises above the mark X. Now allow the liquid to fall freely through the capillary up to the mark X and start stopwatch and note the time T1 for the flow of liquid from mark X to Y. Repeat this procedure, means suck up the liquid until it rises above the mark and stop and allow the liquid to fall freely through the capillary up to the mark X and start the stopwatch. Note down the time T1 for the flow of liquid from mark X to Y. Repeat this procedure until to get 3 concordant readings. After taking these readings of water, now remove the liquid and clean and dry the viscometer again. After that, repeat the experiment by taking the same volume of other liquid. This experiment we are going to taking ethanol. Take the given liquid and note down the time taken T2 for its flow, and from the X to Y take the 3 concordant readings. Now note down the room temperature, degree Celsius. Note down the time T1 here. T1 for time flow for water, and this is the mean, and time flow for liquid, this is the mean. Okay, now room temperature we already noted, and viscosity of the water at ambient room temperature. What is the viscosity of water? Okay, that is the recorded value, constant value. Next, after getting this reading, note down the and after getting this reading, substitute these values to the Poisson's equation. We already know the density of the liquid as well as density of the water as well as liquid. Substitute the values to this Poisson's equation. Relative viscosity of the given liquid, eta1 divided by eta2 is equal to d1 t1 divided by d2 t2. Sorry, d2 t2 divided by d1 d1. N1 is the viscosity coefficient of the water, N2 means eta2 is the viscosity coefficient of given liquid. Substitute the value, we will get this equation. Eta2 means we want to calculate eta2 means viscosity coefficient of a given liquid. Substitute the value, we will get the answer. Clear? Means next, finally report this viscosity, means absolute viscosity of given liquid N2 at particular temperature is centipoise. To perform this experiment, what are the precautions we have to take? Carefully introduce the solution into the viscometer to avoid the formation of air bubbles, and flow time and density of the solution should be carefully determined, and there should no turbidity in the liquid. Clear? Thank you. Then the demonstration of this experiment now we will explain below this video. Thank you again.